viewing, but it was easy as compared to 2. Yeah, that was actually true. Like 3 was much. That's the reason I just say, whenever you are, even if in online assessment, even if you're stuck, let's say if you have 3 problems, if you're stuck at, let's say, problem number 2, still go and see problem number 3 as well. For sure, it is actually very beneficial. B के binary search वाली approach एक बार बता सकते हैं. See, it's just that in B you have to just pick any number. For sure, any number would be same out of all these numbers. So if you have 1, 2, 3, 4. So if you will make some number, it needs to become equal to either 1, 2, or 3 or 4. So you can just choose, let's say, any number. 1, 2, 3, or 4, and then just start with it. But I'll not recommend binary search in this. Neither it is intuitional nor it is complexity wise better. So no point of actually thinking of as binary searching question number 2. So that is one case. But yeah, I will actually go on the entire intuitional, like how to think, what to think, and all that stuff for actually this question of question number 2 which you had. But apart from that, yeah, but if the folks are joining, can you please smash that like baby to 10 likes? Yeah, तुम 18 लोग हो, 15 मांग सकते हैं, but still like 10, 15, whatsoever your Shraddha Astha is. If you have Astha, then it's great. If not, then Shraddha will work. Puja though, it's always work. बस 2 किए, no worries, Ekansh, no worries. Actually, like see, question 2 was a bit tricky, but if you had gone via the proper intuition, it should have been done. Question 4 was actually more trickier than anyone, but it was not that much hard. It's just a small thing. If you just grab that, okay, you would be able to solve it, because it's just a simple sliding window kind of stuff. In question 4 as well, 3 was easiest compared to that was correct. Shubham, yes. शुभम आर्यन, हाय, यस आई. भाई जब मैं क्यू को पहली बार देखता हूँ तब सॉल्व नहीं, क्वेश्चन को पहले देखता हूँ सॉल्व नहीं होता, लेकिन जब मैं बहुत थोड़ा सा भी हिंट देख लेता हूँ, बहुत थोड़ा सा, तब सॉल्व कर लेता हूँ खुद. या दैट इज व्हाट इज इट इज कॉल्ड एज बिल्डिंग इंट्यूशन आउट ऑफ एनी प्रॉब्लम. If you see it, and if in the glance you cannot, because you don't know the actual hint, like you can't start off with, because see, what we teach here is just grabbing out hints from the question itself, from the constraints itself. So that hint which you need to grab from the question itself, you are just looking at this, okay, oh, it was the hint which I needed to grab from the question. So that is what we need to learn, is how to grab the hints from question itself. That is what we study when we study of, okay, how to build the intuition, how to actually go in the flow from question description to what point to pick from, start from that point and then go to other point, then go to other point. It is that what we primarily focus on. So yeah, but yeah, if we have 24 folks, can we reach rise to 15? That would be super great. We will be starting in just 1 minute or so, because question 1 and question 3 are pretty easy. Question 2 I will spend a bit time. Question 4 I will spend a bit more time, because question 4 was actually good. बस ऑप्टिमाइजेशन नहीं हुआ, सेकेंड वॉलेट में TLE आ गया था. सी फर्स्टली आई हैव सीन मेनी पीपल जस्ट सेइंग, लाइक देवेंद्र, मेनी पीपल जस्ट सेइंग TLE आ गया था. सी, you before even coding, you must be knowing that it will give you TLE, right? Then why you even code it at the first place? It's not an interview, right? You should actually think of a better solution than that, because for sure the constraints itself speak louder than actually the questions, that what will actually be applied on this, right? So that is for sure. If you are think of something which like in turn gave TLE, you must be knowing pre-ahead that it would be giving TLE. Then optimizing won't work. If you know, okay, it's a constraint, then you would know, okay, this can be applied, this can be applied, and so on and so forth. Cool. Second में ही सारा टाइम चला गया. That's the reason I just said, Dhruv, कि if you think that question 2 is a bit hard or you cannot do it, please at least have a glance at question number 3. For me also it has happened many times. Yeah, folks are 28. Can we please resize to 20? Yeah, you are just regular, right? Many of you must be regular, for sure. Then yeah, there's a standard Riti Rivaj which we follow. Please, cool. Dhruv, second message. Yeah, that's it. I was saying that please spend time to every problem. Even if you do question number 2, you like, let's say you cannot do question number 2. Please look at question number 3 as well. It will be very, very, very helpful. Bhaiya, how to tackle these operations and sub-array type of problems? Is there a particular good set of questions which can help us? See, if you just go on to our ESA 169 series, you will just specifically see key you will have sliding window, 2-pointer and arrays question. Sliding window will actually make you much more familiar with these kind of sub array problems. So I highly recommend go and do that. If you want more after you have done those, still if you want more, then you can just go and watch the array intuition building playlist. In this we have mixture of arrays, 2-pointers and also sliding window. So with that you will you will get much better in actually these kind of problems of sliding windows, 2-pointers and arrays. And it's just moving in the arrays, it's primarily just 2-pointers kind of moving like this, and that you will just get familiar. Hello bro, I was able to solve the first 3. Great Shubhamari. Second question आया ही नहीं, approach कैसे build करें? That is, see, second question, at every point, at every word will say something. Every word will say something. From that itself we can just start to build. Even a small hint is just a progress to the question. We will see. No worries on that part, but yeah, we will see. Sandhya, Devendra, just to build the approach, first 3 was easy AF. Yeah, like for those who have just been familiar with these kind of problems, it will be very easy. For those who are not, as you will go and watch videos or watch solutions or watch the intuition and stuff, you will actually get to know about it. Barish aa rahi hai. Okay bhaiya, cool. Let's start with the actually problems itself. Because hello Kushagra, hello. Cool. The first one, pretty yeah. Please, we have 34 guys joining in. Can we please smash the like with 25 likes? We will just quickly wrapping up question number 1, then quickly going on to question number 2. It's actually very good. Sum of scores of special element is just actually the implementation question. Just going on that, okay, it's a one indexed integer array called as nums. Please mark the words. It is one index, which means indexing starts from 1, 2, 3 and so on and so forth, not from 0, 1 and 2. Cool. An element nums of I is called as special if basically I divides n. So basically if we have I which means 1, 2, 3, 4, so indexing 1 based if 4, if let's say n is fixed for this, n is 4, it's just the number of elements in this. If 4 mod 1, why mod 1 is the index of this first element. If it is actually 0, which means if n is divisible by I, then simply add the square of that particular element, nums of I, and by this you can simply add in your answer. You will see that, okay, 1 divides 4, 2 divides 4 and 4 divides 4. That's the reason I just added a square of sums, and by this you can simply get your answer itself. Constraints, no matter, it doesn't matter as such. Simply initialize the sum variable, then going on to every of those indexes and just asking, hey bro, n mod I plus 1. Why I plus 1? Because my indexing is 0 based of the array, but in the question it said that the indexing will be 1 based. So basically adding a plus 1 to actually get the 1 based indexing. If it is actually a 0, then I can simply add in my answer sum, which is the sum. I can add the square of that particular element, and with this Saurajit Samantha ITA, first time ever, thank you for, like, legit first time ever someone has did this, so thank you Saurajit a lot, like legit. It's actually great. Like I don't know how to react to this, but yeah, it's not as such required, but still it felt so good. I don't know why, but yeah, thank you Saurajit. I don't know why, but yeah, it was the first time we got something like this. But yeah, cool. Now going back to actually we have the nums of I into nums of I, simply getting it and simply getting the sum. You will simply get the sum of all the numbers in which n mod I plus 1 is there, and by simply this you can just simply solve the first question. It's very easy. Very easy problem. Let's quickly go on to question number 2. It's actually very good. right? And many people have just spoken that, okay, they could not understand how to build, how to start off with it. We will see that from every point, how we can grab what we can actually think of. Cool. We are having a zero index integer array. Please listen this very carefully, right? Because you should be knowing how to grab from what to start at, right? Cool. You are giving a zero index integer array called as nums and a non-negative integer k. Cool. You have nums, you have an integer k. That's it. Cool. In one operation, you can do the following. Choose any index I which has not been chosen, which means if once you choose an index, it cannot be modified again. When you choose an index I, then what you can do is, and you can choose any index in the entire array, then what you can do is replace that number, what you have chosen at the index I, you would have a number. You can replace that number with any number from nums of I minus k to nums of I plus k, which means if I choose this number 2, then I can replace this number from any number starting from 2. Or let's say, okay, if I have this number 1, I can replace this number 1 with any number from 1 minus 2 to actually 1 plus 2, which is actually saying I can replace this 1 with any number from a minus 1 to actually 3. I can replace this number 1 with any number from minus 1 to 3. I can replace that. Cool. Now, what I want is, the beauty of the array is the length of the longest subsequence consisting of equal elements. Cool. What I want is the longest subsequence. Great. What I want is the equal elements. Ultimately, my aim, my target is to make elements as equal. Please remember this fact. It's a very, very, very important stuff. My ultimate aim in my mind is to make all as much elements as equal. So basically, my ultimate aim would be to make many elements as equal. Cool. What I will do is make the elements as equal. Now, again, going back, I will need the subsequence, which means order of element is not important. Again, another thing. Please, that's the reason I just said I need the longest subsequence, which means I want the longest, but I also want the subsequence. Subsequence saying that order of the elements would not be important. Again, I want the equal elements. What ultimately my aim is applying this operation such that the more elements become equal to each other. Cool. Return the maximum possible length, which means I just need to make as many elements as equal as possible. For sure, if it is said it is a subsequence, which means the order is not important. So for sure, one thing can come in my mind is maybe I can do the sorting and stuff. Maybe, because order is not important at all. So maybe I can do it. But yeah, I have no valid reason to actually sort it down. So please, it's just an idea or back of mind. Okay, maybe I can do it, but I have no idea if it should be sorted or not. We have not seen anything like that so far. Cool. Now, maximum possible beauty of the array of nums after applying the operations any number of times. Again, another thing. You can apply this operation any number of times. Cool. Now, you just say, okay, at every index, you can just modify this only once. So that is one fun thing. And for sure, subsequence is any element in any order you are just given. Now, coming back to what I would want by looking at the example. See, firstly, when you look at the example, please don't look at the explanation. From what you have read so far, try to build the answer out of this. So what I would want is, I have 1, 2, 4, 6. What I would want is, I would like to make every element maybe equal to 2, maybe equal to 4, maybe equal to 6, or maybe equal to 1. So what I will do is, in my mind, I will try to make, let's say, every element equal to 2. So 2 is already there. 1, can I make it equal to 2? Yeah, I can bring it to 2. For sure, I can bring this 1 to 2 by adding a number and it will bring in. For 4, I can reduce this number and bring it to 2. Okay. For 6, I cannot reduce and bring it to 2. So for sure, maybe I have not read the examples. I have not read the explanation so far. I have just read, okay, what I can do to actually bring in number equal to, because ultimately my aim was to bring in numbers equal. So I just did, okay, let's bring every number, try to bring as many numbers as possible equal to 2. Okay, I can just bring in every number equal to 2 by just saying this. So what I thought was, okay, what I can do is I can go at every element and will try to make it equal to that element. So what I could do have done was, okay, it is like this. I will choose at any point in time equal to one element and I will try to make every element equal to this. Again, every element equal to this. And what operation I can do is, I can increase this number or I can decrease this number. I can increase this number, I can decrease this number. I can increase this number, I can decrease this number. Now, if I need to reach my 1 to actually 2, I need to increase it. If I need to reach my number 6 to actually I have to decrease it. So one thing I for sure know, if I just can represent this number in the linear form, which means 1 2 4 6, an idea can come in my mind is I can increase the left numbers to actually reach to 2. I can decrease the right numbers to actually try to reach to 2. So by this, oh, and yeah, it means I can just sort it down. Oh, so what I can do is I can just try to sort it down, and for sure I can sort it down because we saw earlier also that okay, I have a subsequence, which means I can sort it down as well. So that is how you know, okay, you got to know that okay, you can sort it down to actually try to bring in the numbers together as possible. Now again, if you go back and see what will happen, you have the constraints as 1e5. So for every element, you cannot go back in the left side. You cannot go back in the right side and will ask everyone, hey bro, can you please bring me together? Can you please bring all the numbers equal to me? You cannot do that. And also, if you are thinking, okay, I will take the prefix sum, I will take the suffix sum, then also it is one thing, okay, what if you take the prefix sum or the suffix sum, but let's say the number is super close to this number 2 and it is super far to, let's say, this number 2. So if it is a super far number, it won't be able to, let's say, okay, let's say take it as example as, okay, it is 3 and it is a 6, or let's say it is a 5. Cool. And for sure, again, my thing is that, okay, I can just bring every number to go to 2. So if I just take the prefix sums, okay, it is 3, it is 5, so for sure it is 8. Maybe I can subtract minus 2 into k, and because these numbers are 2, so I can just bring everyone equal to 2. Can I do it? Or else other cases, maybe I will just think of, oh, I have to go at every element and will ask him, can I bring you down here? Can I bring you down here? Can I bring you down here? So individually I have to go and ask every element. Is it required? Let's see how. So for sure I got to know that, okay, something like that of a suffix sum or prefix sum would not work, because suffix sum, which means it will just say the sum of all the elements, but individually I have the limit on every element. It can only be increased up till k. It can only be increased up till k. It can happen that it is being increased very less, but it can happen it needs to increase very much. But still, if we just add this part, then it will be less than equal to 2 into k, or just k for every element, k. So it's just two elements, so it's 2 into k. So I know, okay, suffix sum or prefix sum might not work. It is, see, that is how I am just trying to actually find what will work. Cool. So one thing I got to know, okay, I have just sorted it down, but I know one thing, okay, suffix and prefix sum might not work. Let's think of something else. Now, ultimately, my aim was to bring as many elements equal together, right? So what I can do is, if I can make, for sure, I'll try to now take the range of numbers. Let's say I start with this number. Now, what ultimately I was doing is I was bringing this number together and this number together, which means it is just saying to me that, okay, I can bring these numbers together. All these numbers I can bring in together, which means I can bring it here, I can bring it here. Now, rather than just bringing every number equal to one number, how about I just ask him, whatsoever you are at any point of time, is your difference less than equal to what my difference is allowed? So you know that for any two elements to actually become equal, if I have two extreme elements, very extreme elements, let's take it as one element as 2, other elements as 4. If I want to make both of them equal, I can easily make of them. I can add a plus 2. Let's say the k is 2. I can add a plus 2 to bring in a 2, and I can subtract a minus 2 to bring in a 2. So for sure, I can make both of them equal. So for sure, I know if I have two extreme elements, so for sure, if the difference is less than equal to 2 into k, I can bring both of them together. So rather than going on the entire, and I know it is sorted, so I can kind of say that if I can just choose two extreme points, everything inside that extreme points, if I choose two extreme points, this and this, let's say, so everything inside of this extreme points can for sure come together if these two can come together at one point, for sure any internal point we can transform it to come together. So ultimately my aim was to actually bring everything to one value. Rather than bringing to a very specific value, I just took, okay, let's take it as a range, and from that range itself, what I will try to do is I will try to know, okay, if I have some minimum range, like minimum value, if I have some maximum value, I know if it is in a range. And what I say a range is that, okay, maximum minus minimum, it should be less than equal to 2 into k. If it is more, which means it is out of range, so I have to do something else. But now from this point I sorted down, I tried multiple stuffs, I tried prefix and suffix sums, it didn't work out. And then we just thought, okay, what we can do is we can get some range. Oh, range we have an array, for sure. It just boiled it down to, I can specifically start working on the range itself. So now I can just think, okay, it's kind of a window. Range is a window. So I can think, okay, if I have one window with me, I have simply one window with me like this. Now, if it is a good window or not, how to know that part? Simply going on and checking. If it's last, which means the pointer j and the pointer i, if j minus i, if it is a less j minus i, let's say if it is a 0, 1 and 2, so simply j minus i is just saying 2 minus 1, 2 minus 0 plus 1. So just say, okay, your length is nothing but j minus I plus 1. If it actually is, see, j minus I is when I say j minus I just meant the numbers itself. So it's nums of j minus nums of I. But forget that. Simply saying that if your number difference, if it is less than 2k, your range is good. Keep on expanding your range. Let's say your j would have been here. Cool, good. Your nums of j minus nums of I, it is less than equal to 2 into k. Simply keep on expanding your range, and by this, ultimately you will just get to know, okay, I have this I have this j, for sure I can, here also it is less than equal to k, I will again try to expand my range. Now it is not possible. If it is not, simply go and increment your I, and now try to check for the new range itself. If it is a range, now try to check for this. So now we transformed, bringing the numbers from every number bringing into one value. We just said, okay, I will just try for a range to bring in, and for sure I can know the minimum and the maximum of that range, and with that I can just try to bring in the minimum and the maximum to one value for sure, by easily saying if that difference is less than 2 into k, for sure every value I can bring in together. And that is how we transformed, taking every number, rather taking every number, take a range and expand that range. And how to know that range is possible or not? Simply checking, okay, if it is a range right now I have chosen, which means I is here and j is here, and when I say a range, it is simply a sliding window. Simply fix your I, expand your j until your j is possible to be expanded. If it is possible, simply expand it. Simply keep on expanding. If it is not possible, when I say possible, I simply mean that your nums of j minus nums of I should be less than equal to 2 into k. As soon as it becomes more than 2 into k, simply increment your I and simply keep on going forward. And that's how you can simply get the maximum sub-array length. Right? And that maximum sub-array length will just say me, okay, I can make all these elements as equal, which means I can ultimately make all these elements as equal. And this how I can say your subsequence will have the equal length, maximum equal length. That is all what we have done. This question itself, we have taken a j, we have taken an I, simply 2 pointers, simply doing a sliding window approach until my j is less than end, which means until my j goes to the end. I'll simply go and ask him if nums of j minus nums of I, if it is more than my 2 into k, for sure I need to increment my I itself. So I'll increment my I. While if it is less, for sure I can update my answer with the maximum of answer, because ultimately I'm concerned about the answer length, which is the sub-array length. So I'll simply keep on updating my answer with the maximum of j minus I plus 1, which is the length of that sub-array from I to j. And for sure at every point keep on incrementing your j, because ultimately your j will keep on moving ahead at every point of time, because it's a linear stuff, which is a 2-pointer sliding window part. That is the whole. You can simply get your maximum length. That is how you can just simply get to know from every point how you will think of something, that you will actually discard that and think for something better, and then think for something better, and so on and so forth. That's how you can simply keep on going in the entire problem. I hope that you guys got it. If yes, then please smash that like button to 45 likes. that would be super great. 45 likes, that would be, यार चलता है इतना बनता है, right? Cool. Let's quickly go on to the comments. Quickly. सेकंड क्वेश्चन आया ही नहीं, अप्रोच ये तो हो गया था. ओके भैया, हेलो कुशाग्र, लेट्स गो. कांग्रेट्स फॉर 25K पराग, थैंक यू सो मच. सौरजीत अगेन थैंक यू सो मच ब्रो. लाइक पता नहीं यार, मतलब ऑल्दो लाइक अंदर से वो हो रहा है कि भाई नहीं ये क्या हो रहा है, बट या लाइक इट जस्ट एक्चुअली समथिंग न्यू which we have got, but yeah, that is actually nice. Used one based indexing giving runtime error. Why using one based indexing giving runtime error on what? भाई आज मेरा पहला कॉन्टेस्ट था, 2 क्वेश्चन बना, फर्स्ट एंड थर्ड. इस कॉन्टेस्ट की रेटिंग कब तक आएगी? आ जाती है at the same time, but yeah, there's some glitch going on, so probably. Kamal, how much time it takes and on average for you to solve all 4 problems in the Leetcode contest? Depends upon the problem itself. Yeah, highly depends on the problem. Highly depends. There are cases when the problem 2 is the problem of DP itself. Still, it's very easy for me. But there are few problems that okay, it's just something kind of a simple array problem, and still it would take time. So it's very variable. But the best have gone is 40 minutes for all 4 problems, and the worst is for sure 1.5 hours. DFS 3 to 4 days. Shubham, अच्छा हाँ, reflect on the page itself, it's 3 to 4 days. Yeah, ये given test case से इतना पता ही नहीं चलता. Yeah, there are cases when the test case won't give you many stuff, but you have to see. The best thing I recommend is blindly read the test case and try to, like, without even seeing the explanation, just from yourself try to see what you think of the explanation. Is it actually working? Because the actual explanation of the test case, it can actually distract you from the thinking which you could have thought. So it is one thing, please read the test case by simply just seeing the question and building your answer by yourself. As soon as you have got some intuition, you can read the actual explanation itself. But yeah, I recommend that. Why can't we take a median and just make everything equal to that? That's what I showed you, that it is not possible to make everything equal to that, because if for every element you have a limit. Okay, you can increase every element to k or decrease every element to k only. If you will take the median and will take for every element, then for sure the sum part will come in picture, which will in turn give you wrong answer. I thought a range of numbers as well as the weighted median concept here. Yeah, that's how what I told. We just can think of bring out any stuff. Still, you could have solved it by weighted median also, but then still it will become way too much complex a lot. Sliding window up easy hai. Yeah, see, even if you have issues in sliding window or any concept like that, feel free to check the DSA 169Cs, and it's not important to do the entire thing. If you think your sliding window part is not well done, just simply grab that question of sliding window and just simply solve it. If you still think it is not done well, then simply go on in the array intuition building playlist by Aryan Mittal. In this array intuition building playlist, we have the questions of arrays, 2 pointers and sliding windows, all mixed and together, and did the intuition wise explanation also. So yeah, from that you can just get to know it. 2 into k kahan se aaya? I showed you, right? For this number right here, you will have, I can increase this number and decrease this number. So for sure, I can increase it to k, increase it to k and decrease this to k. That is the reason k. So if the difference between 2 element is 2 into k, for sure they can be brought together. That is how it came in as 2 into k. I thought of the same thing but kept on increasing the j pointer. Yeah, j pointer will always keep on increasing, but you have to put a point. Okay, if I cannot increase my j further, for sure the j pointer will go ahead, but still I will also need to go next. Cool. That was wrong on my part. What is line sweep algorithm? It's just simply going on. If you have a line, then you will choose a point and you will just try to sweep this point. Simply you can just think it of as a kind of an medium intermediate sliding window, but it has a slight modification as well, so keep on that point. But yeah, that won't be required as such. Simply you can just think of, please don't go in the algorithm wise. Okay, that's one algorithm, that is another, that's another. Just simply go on for the concept what you have got. Cool. How much time take it on average for you to solve all problems? That I answer, Kamal. 8 minutes. It's a scaling algorithm. Yeah, you can just name it as Shalini. Congrats and hats off to you. You do contest. You do every contest and every pod along with job here, struggling to maintain the consistency. See, my motivation is just you guys. If you not had been there, I would have not done it. So, shout out to you guys. But yeah, why are we increasing I by just 1 when it becomes invalid? We should increase I till it becomes valid again. Yeah, at every increase of I, you are checking the validity again. If it is invalid, then still you will increase I. So ultimately, at every point of time, you are increasing I just once. But if again it is invalid, it will again increase. So ultimately, it will keep on increasing until it will keep on increasing until your I actually becomes valid. Cool. And why are we increasing it together? And it worked. Shubhrat. Okay. Learned a lot from you. Thank you so much, Scratch. Cool. Let's quickly jump on to question number 3. It's very, very, very easy. In comparison to question number 2, it's very easy. It's very straightforward. Very straightforward. Cool. But before that, can we please smash that like? Will be 255 likes. Just 4 more. That would be super great. Cool. The problem 2 is minimum index of a valid split. Very, very easy. I'll just explain that in my terms, or you can just read the question itself. We just say any element as dominant. Let's say any element X as dominant if the frequency of X into 2 is more than the size of the array itself, which means there can be just one dominant element, and it is very much for sure that, okay, it can have at most one dominant element. Why? If the array is of this height, let's say it is the median of the array, to actually become the frequency into 2 more than the size of the array, let's say if it is equal, then into 2 will be actually be like this. It will be equal to M, right? But if it needs to be more, so it needs to be more than half, right? It needs to be more than half of the entire array itself. So for sure, the dominant element will have the frequency more than the half length of the array itself. That's the reason it just says, okay, it can be at most one dominant element, because if it needs to have other element which is dominant also, it needs to have the frequency more than half, which is not possible at itself. So for sure, I can have at most one dominant element. When I say dominant, its frequency into 2 is actually more than M in the array itself. Now, okay, moving ahead, we are having n nums. Cool, no worries. Now we can split my nums at an index I, and when I split, I will break it into nums of 0, I. Which means if I have a split at this particular index I, first, like the left part will become this, right part will become this, simply from 0 to I and from I plus 1 to n minus 1. As simple as that. Cool. Now, what I am saying is that this and this have the same dominant element. Firstly, if I have one dominant element as X, for sure, it will be the dominant element entirely. It will have the maximum frequency, right? So for sure, if I will break this into left part and right part, let's say it is up to here, right? So if I break it into left part and right part, both left part and right part would have the same dominant element as X, because it is the only dominant element it is in my array. So I have to find up index I such that the dominant element X which I have found above, it is both the dominant element of the left part and the dominant element of the right part also. So what is that particular I? And simply how to know if any element is dominant or not? Simply go and find the frequency of that element in the entire this particular array from 0 to I, and we'll see if the frequency into 2 is more than the size of this particular sub array, which is nothing but I plus 1. If it is there, then simply saying, okay, that element X is dominant in the left part. If it is the same for the right part also, just simply saying frequency into 2 is more than equal to the whole size of the array, which is n minus 1 minus I plus 1 plus 1. N minus 1 minus I plus 1 plus 1. Cool. That is how you can simply solve it. As simple as that. Constraints are pretty Pretty simple. Just saying O of 1 is 5, which means what I will do is, I know if my X is the dominant element. So firstly, I will go and find, okay, what actual element is the dominant element in my entire array. And when I've got the entire element, when I've got the X as the dominant element, then I can just simply go and at every point of time, okay, if I have this array as the sub array, I'll go at every index I, and I'll go and ask, hey bro, at every point, if the, and I will just keep the count of that dominant element X, which means I will keep the count of X in the left part. Let's say it has count 1. I will keep the X, I'll keep the count of the X in the right part. It will be nothing but whatsoever count I had. Let's say the X is the element and its count is, let's say, C. So if I know the count is C, and right now I'm going from left to right, I'm keeping track of this count of X in the left part, it is C1. So the right part ultimately count will automatically become a C minus C1, which is actually a C2 count, which is the count of X in the right part. And I'll just simply go and say, ask him if this C1 into 2, if it is more than the length of this particular left part, and if this C2 into 2, if it is more than the length of the right part. If it is the case, then simply, if it is the case, then simply go and update your answer with the shortest index, because as soon as you are moving from left to right, simply as soon as you found any index possible, simply go and return that index. And ultimately, if you have swapped the entire array and still no possible such index is there, simply return a -1, and that's how you can simply solve it. It's a very straightforward question. That's the reason I just suggested that it was very good if you could have solved this question first in compared to question number 2, because it was much easier. And while solving, you could have also viewed the number of submissions. It just indicates number of submissions, that which problem is much easier. Now, examples pretty simple. We can just simply do it. Let's quickly jump onto the code. It's very simple. Firstly, I just grabbed the frequency of every element. Now, to just get the majority element, you can use the Boyer-Moore algorithm. But yeah, it's not as such hard and fast required. If you want, you can use it. It's just a contest for you. So simply just go as soon as possible. Don't complicate stuff. I'll recommend that. Else, what you want to do is you want your wish. But yeah, simply firstly grabbing the frequency of every element, because ultimately I'm concerned about the frequency. I'm concerned about the element having the maximum frequency. Here I will just go and ask what is the dominant element I have got so far. Now, as soon as I have got the dominant element, I will go and try for every index to check. Okay, I will try for every split index I. When I say every split index I'll go and say, okay, firstly, as I'm going on from left to right, I will keep on, as soon as I'm finding any dominant element, I will keep on increasing my count. It is the left count of the left sub array, right? And right count, which is the count 2, which is of the right sub array, will be nothing but the frequency of that minus count. It is nothing but count 2 is the right count, which is the count of the right sub array. Count is nothing but the count of the left sub array. Okay, I've got the left count, I've got the right count. I will simply go and ask if the count into 2, if it is more than I plus 1, which is the length of the left sub array. Count 2 into 2 if it is more than n minus I minus 1, which is the count, which is the length of the right sub array. If both the cases are true, which means if both the cases are true, then simply update your split index with actually the current index I, and simply break it down, because you have got the smallest index possible, and simply return that split index. By this, you can simply solve your answer. Cool. Let's quickly go on to question number 3. But before that, can we smash that like maybe 260 likes? Yeah, 60 likes. Yeah, just one more like. That would be super great. Just one more. 60. Cool. Let's quickly jump on to question number 4. It's actually good. Not that hard. I should say it's a medium to very small hard. Like not hard at all. Cool. Let's see. Yes, I was able to solve it within 5 minutes. Yeah, third was easy. Then question number 2. Thank you, bro. First product based company mein hoga selection. Oh, Yash Bankar is here. Thanks a lot to you guys. Just thanks to you, Yash Bankar too. Cool. Now going on to question number 4. It's very, I should say it's actually very easy. If you have not solved it, it's just that you could not got the hint of how to actually start off. If you would have known how to start off, you would have solved it. Cool. Let's quickly see. length of the longest valid substring. What it says, you are having a string as word, now, and also an array of string as forbidden. Okay, word, I have a string, entire word string. I have the string of forbiddens as well. Now coming on to a string is called as valid. A substring, basically a string here is it's written, but yeah, ultimately I'm concerned about the substring. A string is called as valid if none of the substrings are present in forbidden. Great. Now I'm concerned about that the none of these substrings of that particular string. If I choose a string, none of these substrings should be in that forbidden string, in that forbidden list of strings. Now return the length of the longest valid substring. Now I have this string of word, I have to return the length of the longest valid substring. Let's say it is this. Let's say it is not actually, but yeah, let's say it is this. Then in this, when I say this as the longest valid substring, I mean every substring of this particular substring, let's say name it as a string S2. Every particular substring of S2 should not be in this, for sure. Here you will see A is here, so for sure it is not a valid substring of my S. So I need to return the longest valid substring of my string word. Now coming on to, as soon as something like this comes in, firstly, you could not get any hint from the question itself. No hints, no fucks given here. No, nothing. It's just a straightforward question. No hints at all. To get the hints, we can look at the example. Now, look in the example, we cannot get any hints at all because it's straightforward. Choose the substrings, we can make n square such substrings. In that, considering I will check for every substring. Firstly, I cannot produce even n square substrings, so question is done there itself. There comes in the help of constraints, because we know that okay, we can't get the help from the code explanation. We cannot get the help from the example, because example is also straightforward. Look at the constraints. Constraint says that the word length is 25. Okay, the length of word is 25. For sure, I cannot produce n square substrings. For sure, I cannot. Which means I need to think of something linear or something, maybe n log n, to actually, because see, it is, if it is n, then I can have some constants. Constants can always comes in, but yeah, I cannot have an n square or something like that. I can have an n log n or something like that, but yeah, I cannot have n square, which means I cannot produce substrings at all. Cool. My forbidden length is actually 25 also, which means okay, for every let's say, even if I choose any substring, I cannot go in this entire forbidden again and again. So for sure, one thing, I am only concerned about every string of this forbidden string, which means I just need to know, okay, if this string is forbidden or not. So rather than going on to the entire forbidden, I would just take any unordered map or an unordered set to actually know if that substring is forbidden or not. So one thing I got to know, okay, it is actually a vector of strings. So, and ultimately I'm concerned about if that substring is forbidden or not. So simply just ask him, can you convert this vector of strings to actually an unordered set or an unordered map to actually know if that string is forbidden or not. Cool. That is the use of this thing which we have used it. Now comes the another thing. Oh, every string is of length 10 at max. Now, it can be a jackpot for you. It is one constraint. Now, why is such a specific constraint on the length of every string? Can't we use it? Because ultimately we know one thing. I have this O of n. I know I can do a O of n log n or something like that. But yeah, I can also do a O of n into some constant. So if I can utilize this particular forbidden length as 10, I would know that the length will always be 10. Then maybe I can solve my answer. So from the constraints, I'm trying to build the algo that, okay, what I could be able to solve by these constraints. Now, coming back to, okay, I can utilize the length, which means that the forbidden length, it can at max go up to length of 10. Now, coming back, how I can utilize that. Again, coming back to what simply you can do is simply make your string of words. Now, every of this gola or the circle you can say is representing me every character of words. Just imagine this as words array, words string, and this gola, which means this circles, represent every character of my words. Now, ultimately what we saw earlier was, I'm concerned about at every point of time. Now, as I have earlier spoken also, just try to go in the mid and try to see how your algo will work. Now, as I was also looking one thing. Maybe I can do a n into c kind of algo. Maybe. Which means I can just try for the forbidden length of length 10. Which means if I start with this particular character as the start of my substring, then I can simply go on and try to check for the next 10 characters. Okay. If it is 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. Cool. Make another golas in this. 9, 10. Right? Now, let's say it is this. Again, this. Cool. Now, I know one thing for sure. If I'm starting with this substring from here, if I'm starting my substring from here itself, then for sure I need to check only the length of 10. But, is it true? Nah. What if, okay, I just check, okay, if none of this, when I say I will just try to check the length of 10, I will just try to check, okay, if this is a character, right? Or let's say it is any character. Let's imagine it as any character. Wait a second, what happens? Yeah. I will just imagine, I'll just try, okay, if this is inside my forbidden string or not, if it is, and so on and so forth, until the length of 10, because I know it's a maximum length, I can just look for, but, is it required? Then let's say if none of these strings, which means this string, which means I'm just considering this as the main string, main character, and starting from this string particularly, or this string, if none of these strings is actually in the forbidden, can you just say that, okay, this particular length is actually good? No, you cannot. Because for sure, again, the next thing will start from, okay, you will just go and ask every of the next character, hey bro, are you good? Which means, are you good? Are you not in the forbidden string? You will go and ask in the next character also. So again, Aryan, it is the same stuff. I will go and ask him. Then for this particular substring, I will go and again ask him. I will go and again ask him. So it will again become a O of n square kind of stuff. Then what are you optimizing? Yeah, correct. You are correct. Again, it is becoming O of n square kind of stuff. But we could have utilized this constraint, right? We know if the length is this particular, what if we can only check the starting, because we know, okay, I am starting from this index I. I know I can only check the substrings from I itself. So I know I can check the substrings, but then again the issue comes in that I have to repeat the same process for the next index also. Which means, what if I had known the answer for the next index? What if the answer for next index, let's say the index is any index, let's say it is as y. Let's say for this answer index y, let's say I know the answer for this index y if the longest possible substring is at let's say from here to here. Let's imagine. See, start imagining in programming that you can get the answer and then backtrack to get that answer. Right? From constraints, we started to imagine, okay, we can just place an index, we can just try to evaluate for this particular substring of length 10 from that index itself. But then we just figured the problem, okay, we need the answer for the next part also. Then it will again ask for the next part. So why not I just assume that I have the answer for the next part, which means I will assume, okay, I have the answer for the right part. And let's say when I say the answer for the right part, I will just say, okay, the length of this particular substring, which is actually good, which means none of these substring inside this substring is in the forbidden string, then I'll just simply say, okay, it's a good one. So for sure, I know the ending is at here, right? Ending is here, starting is here for this. So I am very good with this particular concept that, okay, the right part, if I can just sort this index down, I can very assuredly say that the right part is already good. So if the right part is good, now for this left part, I can only need to check from this particular index to the index of maximum length, which is nothing but the length can at max go to length of 10. So I can just go and check for this particular all the strings. If it is not in the forbidden string. If it is the case, which means if it is a good, when I say the index I is good, I mean all the substrings starting from index I, and for sure all these substrings, I mean all the substrings of length at max equal to 10, right? Or for sure it should be also less than equal to my end, because end is the limit. It is already good. This part is already good. I'm just trying to accumulate and see if this I, when it will come in, will it actually be a good part or not. So again, I'll go and check if that starting from I, all these substrings of less than equal to length of 10, or ending any one which is lesser. If it is the case, then for sure my I index is good. And for sure I also know one thing from my, I assume one thing. Let's assume that your Y up till end is also a good one. So if it is good one, and again I coming in is a good one, so for sure I can include my I in this particular string as well. So for sure now my new good string will become something like this. That's how you saw your range expanded. Got it? That is how you can simply solve it by simply 2 pointers or sliding window. But you saw one thing, that you assume the answer for right part was there. So why not start from the right part itself? Which means what I will do is I will start from the right itself rather than from the left. I saw that, okay, I need to have the answer for the right. I assume the answer for the right would be present. So why not start from the right part itself? So what I will do is, rather than going from left right, I'll go from right to left. As I go on from right to left, I'll simply know the answer for the right part, because right to left, which means answer was being computed from the right part first. So let's say I am at this index I, right? And I reach it by iterating I here, I here, I here. And when I say I'm at this index I would be knowing for this particular index I plus 1, what is the longest possible substring he could have got. Let's say he could have got the length as this much, which means he have got this length up till here. Now, if you're starting Aryan, how to know? If you're starting simply, you're starting from here itself, it's good, right? It's simply, it should not be in the, if it is just a simple substring, which means your I is here, and also you know that, okay, your end is also here. So you know that, okay, both your I's are here. Simply the substring which you can have is just a one substring. You can just go and ask, if bro, are you in my forbidden string or not? If you are not, I'm good. If you are, then for sure I cannot go on, and I can have to decrease my end also. So I know one thing, at any midpoint of time, which means at this index I would be knowing answer for sure of I plus 1 for me, and for sure for this I plus 1 I also would be knowing up till where it ended, which means up till what point it has a good string length. Right now, let's say I know this part. Okay, I know the end, I know it is there. I will just go and ask for this I, all the substring. When I say all the substrings, I mean from length I plus 10 to actually, and for sure I plus 10, it can't go beyond this. So for sure it should also be bounded by my end, because ultimately what I mean by this is, if you say it is a good length, but still you know that, okay, I plus 1 to E was only the good part. You can extend the good part from the left, because you are moving in the left. So you can extend the good part from here itself. Not you can extend it from here to here, because you already know that it won't be a good part. If it would have been a good part, it would have already been I plus 1 to E would have been here itself and not here. If it is here, which means this part coming in, it was not a good part for this I plus 1, right? So it will expand only in the left. So for sure, if I, starting from I, all the substrings being made, if it is not in the forbidden, I can easily know, okay, it is my new range which I will have. Cool. Again, I will just go back and shift my I. For this, again, it will go and check if all the substrings starting from I, again, it will go and check if it is. Now, if at any point of time, it just asks me, okay, it is good, it is good, it is good. Oh, it is not good. Now, at this point, it just says it is not good. Or let's say, it just says, okay, it is good, it is good, it is not good. Oh, it is not good, which means I cannot have here. For sure, I know one thing, my I plus 1 to end was actually a good string, but I is saying from me to here only is a good string. So for sure, you know that, okay, you can't expand your I beyond this point. So please bring your E to this point itself. So I brought my E to actually the point where my I was trying to expand, but it could not expand because it found a string similar in the forbidden array of forbidden list of strings. So I will bring in my end point back to this point, saying now it is the new valid string which I can take it for the back indexes. Now again my I has been shifted. Again I will just try to go on and go back. Again I is here. I'll go back and again ask him, hey bro, are you good? Are you good? Are you good? Yeah, you are good. So simply you are good. Simply go on back. Again I'll go ask my bro, hey bro, are you good? Are you good? Are you good? Are you good? When I say are you good, you should not, the substring should not be inside my forbidden string, right? Okay, it is good. Now I'll go and ask him, hey bro, are you good? Are you good? Are you good? Oh bro, I am not good. Or like say, oh, like he says, oh bro, I'm not good. Okay bro, at this point you said that you are not good, which means up till here you were good. So for sure bring my end to this point, and please make sure that at every point of time you have I, you have E. At every point of time you are updating your answer simultaneously because you want a maximum length, right? So please at every point update your answers simultaneously. Okay, my end has moved here. Again it will just try to go at this I, and it will go and try to again check. So it is how your I and your end will keep on moving, right? And at every point of time, please keep on updating your answer with the maximum answer possible. Cool. I hope that you guys got the intuition, got the entire explanation, intuition as well. Please smash that like button for 75 likes. That would be super great. We'll quickly jump on to the code explanation itself for this problem. Again, it's very easy. We'll actually see with the picture itself. But yeah, before that, can we please smash that like baby to 75 likes? That would be super great. Going on to the code, it's very simple. We have simply got a few variables, which means the result, which is the final result. Firstly, you know that okay, you have to get every string which is the forbidden string in as short as time as possible, because for every forbidden string you need to know if that is a forbidden string or not. So simply take as an unordered set or an unordered map and simply push in all the forbidden strings in this particular map or a set. By this, in O of 1, or basically O of length of forbidden string, which means if this forbidden string is having one string having the maximum length, let's say as 10, so that will be O of 10. So still constant, yeah, but still by this you can get in the smallest possible time the best string, in smallest possible time the forbidden string which is there. Cool. Now you will simply have the result having the maximum length of your answer. Right pointer, which is the end pointer which I showed you above, starting from the end of this. Now I will have the left pointer itself, which is the left. I will keep on moving in the left. Right will actually be here itself in the extreme right. Now I have the right pointer. I will have, now it is the same as what we have seen. I have the left pointer. After I have the right pointer. Now I need to check for all the substrings starting from this particular left. So all the substrings, but please make sure that all the substrings of length at 10 at max 10, of length at max 10, right? And also ending before this right, because for sure after right it won't be having a good substring, because for sure earlier in the previous step it would have happened that it would have just explained the good substring so far is from here to here, from left plus 1 to right. That's the reason I'm trying to check for left now, right? So I will just say for left, try to check for every substring of length. Let's imagine the other variable as k, which means it will just try to check. K is nothing but to check from left to k, left to k, left to k, left to k. The k will be variable from left, starting from left to actually either right or maybe left plus 10, right? K will actually be going from left, which means k will actually start from the left and will go either to the right or to the left plus 10, whichever is minimum. Cool. I will simply go and say left or left plus 10, because I know the maximum length of my forbidden string, it can be 10, and also right, anyone which is minimum. It will be the length of the substring I can actually try on starting off with this index left. Cool. I know the index is left. I know the length of the substring, which means the end point of the substring which I can try off, right? It is at ending at k. Now I know I have to start from left, end at k, and see what is the substring right now, and that substring left to k, it should not be inside my forbidden string. So I will just go and ask my forbidden string, the thing which I made above, his particular set. I will go and ask him, bro, do you have starting, because it's just a substring, it's just getting a substring from that left to actually of this particular length. It's just getting a substring from, if it is a k here, which means as you saw, your k will move from here to here to here to here, right? So if at any point of time, if a k is here, it will just go and ask what is the substring here. It is given, okay, it will just give me the substring, and I will go and ask if that substring is inside my forbidden set or not. If it is in my forbidden set, okay, great, I cannot move my k ahead, but I know, okay, it is inside my forbidden set, so for sure it is not a good substring I can take. So please bring my end back to my k minus 1. So I will bring my right pointer back to my k minus 1, which will just say me it is the new good substring which you can have, right? So I'll just simply bring my right back to k minus 1, and I can simply break down, because for sure I cannot go my k ahead, because for sure k itself broke here itself, so it's no point to move k ahead. Simply break it down, and for sure at every point of time, which means at every point you are having this, please update your result with the maximum result, which means the right minus left plus 1, maximum length possible, and by this you can simply keep on updating your result with the maximum length possible. That is how you can simply solve this problem. See, what you thought of was to actually utilize that forbidden length value. When you were trying to utilize that, you saw that you need to have the answer for the right part also. So then you thought, let's start from the right itself. Then you start from the right itself, and from right you just build your solution itself, and that's how you can solve the problem. Cool. I hope that you guys got it. Cool. Let's smash that. I will to send 5 likes. Just one more like. That would be great. If you have got it, that would be super great. I'll quickly go and read the comments if you have any doubts, because it's just done. We will just quickly wrap it up in 3-4 minutes. But yeah, that would be great if you can just like this down if you have liked it. If you have got anything, any value, just like सब्सक्रिप्शन तो क्या ही करोगे तुम लोग, तुम तो ऑलरेडी यहीं पर रहते ही हो. तुम घर पर कहाँ जाते हो, तुम यहीं रहते हो ना. So yeah, before that, let's quickly and worked, learned a lot. Cool, thank you so much. Scratch is able to solve it within 5 minutes. Yeah, third was easier than solution. Thank you so much, bro, for the first product of this company. मैं होगा selection. Thank you so much, Yash Bankar. 722 passed in this, but TLE okay. बहुत easy से बताया आपने, second में सोचती रह गई. तनिषा, थैंक यू तनिषा. श्लोक, बट भाई बहुत अच्छा समझा लेते हो आप, ये क्वेश्चन 4 कितना अच्छे से बता रहे. थैंक यू सो मच श्लोक. देवेंद्र वर्मा, मे बी माई ब्रेन इज ब्रेक्ड, आई एम अनेबल टू अंडरस्टैंड अ सिंगल फ्रॉम हियर. सी, it might be happening that you missed something. Just quickly go and watch it, you will for sure get it. It's actually an easy problem for sure. See, usually what happens with me also, I am like, let's say, understanding any problem. It happens in the context itself. I will start thinking of my past experiences, some memory, some bad experience or some good experience, anything. I just start remembering it, and my 15 minutes is just gone. I'm like, what happened? I didn't do any progress. So that is what happens. But yeah, you must have blacked out in between, thinking of something else in your dreams, watching screen, but thinking of something. But then again, you realized you missed many points. But yeah, quickly going back through, it can easily solve. It's a very easy problem. I thought of putting all the forbidden words in the try first. Yeah, that can also be solved. And then check for the words for substrings from I to S10 to N, but couldn't able to implement it. Yeah, that is actually Pulkit. That is actually true. With try also you can solve it very, very, very easily. But implementing a try is pain in ass. So that is fourth. 2-3 बार समझना पड़ेगा. That is up, like entirely. See, I don't think it needs to be understood 2-3 times. It's just a simple sliding window. just having a constraint that you need to know the answer for right part also. That's all. Cool. Me watching live stream, ये 1.5x में क्यों नहीं चल रहा? Okay, amazing explanation. Thank you. Take up. It is easy. Yeah. Hey Aryan, MS Darshan, Kritik, MS Darshan. Hey Aryan. Hey MS Darshan. Dhruv Singh, show the full code. The full code is right here. If I will just show you, it is right here. It is a full code. If you can just have it here itself, it's a full code for you guys. It's actually super clean. Well, like, although you can just implement that in a very unclean way also, but yeah, it's actually very, very, very clean. I missed the constraint hints. See, whenever you cannot grab the hints from actual explanation or the examples, constraints are your god. But yeah, before that, can we smash that like it likes? Smash that like baby to 80 likes. That would be great. Just 3 more. Great. Can you make a video on how to interpret constraints properly? Yeah, I was thinking to make a video on that. For sure, we can bring it down. हमें तो memes याद आने लगे जाते हैं. Correct. I also started remembering memes and stuff, and some good or bad memories also. Try नहीं आता. No worries. You can just go and search try playlist by Aryan Mittal or try intuition playlist by Aryan Mittal. You can just get the playlist. It just has 2-3 problems, or simply go and watch or do the DSA 169 series. It has also 2-3 problems of tries. Simply, it is more than sufficient to solve 2-3 problems of tries, because it is not that much asked. It is a kind of a big complex structural code. If you are good in structural programming, which means pointers and stuff, good for you. If not, then it's a pain in the ass for me, for sure. Try is not an easy part for me. I hate tries. Not sure. It is what it is. It can be asked, so please solve it. For that, go and see the intuition try intuition building playlist by Aryan Mittal, or simply DSA 169 series. You have a question 3 of tries. That is more than sufficient. Simply go and solve it. Parag, how to build self-confidence and stop to compare yourselves to others? Even I don't want to. See, that is something you have to be narcissistic. Just assume you are the best. That will come slowly. See, it works in every field. You have to go on and start assuming, okay, I am the god, I am the best. And that one is having ego, one is having confidence. There's a fine line between it. To grab that fine line, just start solving problems. You have to trick your mind and say again and again, I can solve it. But it will only be tricked when you will actually be able to solve it. So practice problems, give virtual contests. By this, your mind will able to replicate that, okay, you can solve the problems. If you can solve it, then he will just say, okay, क्वेश्चन 2 सॉल्व हो जाएगा, क्वेश्चन 3 सॉल्व हो जाएगा. बाय दिस कि यहाँ ये तो क्वेश्चन सॉल्व हो ही जाता है. आई कैन सॉल्व दिस क्वेश्चन एनी हाउ. आई हैव सॉल्व मेनी क्वेश्चन विच आर मीडियम कैटेगरी. आई ओनली स्टक इन हार्ड. सो फॉर श्योर इफ इट्स अ मीडियम क्वेश्चन, आई कैन फॉर श्योर सॉल्व इट. I can think of something I can bring out from the question. By this, you can easily solve the question itself, right? It's just tricking your brain out, and also your brain is very smart. It will not get tricked unless you work hard. Work hard, trick your brain by just saying, okay, I am the best, I am good, I can do it. And it works for every life, everything. Even if you are pulling off any presentation, if you're pulling off any interview, if you're pulling any girl, if you're pulling any stuff, any competition, any contest, just as you are practicing, just keep on saying, I'm good, I'm the best, and keep on improving too. Please don't stop your improvement. That is all. How many Leetcode questions are enough to apply for Mang? I would say even 169 is enough. Still, Rupesh, still. Practice is important. When I say to grab the logic, it's one thing. But practicing by your own hand with stress, giving virtual contest, solving problems is another thing. So please solve it by yourself. Solving questions is good, but keep on practicing, keep on giving virtual contests, and keep on solving new questions. Right? Can we please smash the like button to 85 likes? We will be ending the stream soon. Thank you so much for watching. Thank you so much for coming in. Thank you so much for helping out. Thank you so much again for all the compliments and stuff. And thank you so much, Swarajit, again. Like, it's not a big deal. Like, it's not a big deal. Like, actually, I can return you that back. But it just feels so good when because someone do something like this. Because see, we are just helping each other out. But this also, it just feels, I don't know why, so good. Yeah, thank you so much, Swarajit, and thank you so much, everyone. Kushagra Mishra, thank you so much. Thank you so much, Akansh. Bye bye. See you. 85 likes. If we can reach before ending the stream, that would be super, super, super great. But yeah, still, thank you so much. That's all. Take care. Thank you so much. It was all. Goodbye. Take care. Bye bye. Bye bye. Cool, 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 cool. Ending the stream right here. That would be it. Cool. Bye bye. See you. Goodbye. Thank you. Thank you. Thank you. Thank you.